Praise the Lord. Hi, everybody. Welcome back to the new chapter. So, dear friends, here comes the new chapter, chapter number 7, permutations and combinations. So, this is the first exercise on permutations and combinations, which is exercise 7.1. Dear students, this is one of the beautiful chapter in mathematics. Now, if you take any competitive exams, you will definitely have questions on permutations and combinations. Okay, hope you have gone through the basics required for permutations. Now, this exercise is purely depending upon the concept of fundamental principle of counting. Okay, well, and most of the questions, almost all the questions in the exercise are statement problems. Okay, so wherever students come across statement problems, they feel it difficult, so you have to be careful enough when I explain the steps neatly. Okay, so let's take up the first question of the exercise. So here comes the first question. So what does it say? How many three-digit numbers can be formed from the digits 1, 2, 3, 4, and 5, assuming that there are two conditions here. This is the most important condition you have to check whenever you are arranging numbers. Okay, now remember, the first condition is repetition of the digits is allowed, and the second case is repetition of the digits is not allowed. Okay, so let's take the solution here. Now here, what is the total number of digits we have? We have total number of digits is 1, 2, 3, 4, 5. That is nothing but 5 digits. Now out of this, how many of the digits which I have to arrange, actually I have to make a 3-digit numbers. So that means your value of R is equal to 3. Okay, therefore, so let us solve this in two methods. One is the formula method. Total permutation, remember, when the repetition is allowed. Okay, so the total permutation would be n power r. Okay, so this is nothing but what is the n here? It is 5, r is 3. So 5 cube. So what is 5 cube? It is 5 into 5 into 5. That is nothing but 5 5s are 25. 25 5s are 125. That is, there are 125 three-digit numbers that can be formed using the digits 1, 2, 3, 4, 5, provided repetition is allowed. Okay, this is the one way. Or there is another way around. Now let us solve the same question by using the fundamental principle of counting. Now look here, we have to make three-digit numbers. So that is definitely of the form hundreds, tens and units, or units, tens and hundreds. Now look here, there are 5 numbers and there are no zeros here. So since 0 is not here, so units place, coming to the units place, any 5 numbers can take the units place, isn't it? Okay, any of these 5 numbers, one can take the units place. Once a number is taken into the units place, in the tens place, again any 5 is allowed because repetition is allowed. That is the condition. Difference between repetition is allowed and not allowed. Okay, tens place can also be filled by any of the 5 numbers, and the hundreds place can also be filled by any of the 5 numbers. Please note down, 0 is not there, because if 0 is there, then 100 place cannot be taken by 0, because if 0 is in the 100 place, it is no longer a 3-digit number. Okay, now you may say about 007, the number of James Bond, whether it is 007 or 100 times 07, it is just 7 itself. Okay, so here, even if you check this by fundamental principle of counting, you will get the same number of digits. So that is 5 into 5 into 5. So that is nothing but 125. Okay, so this is when repetitions are allowed. Sorry, this is the same condition in the different method. Now let us take the second condition where repetitions are not allowed. Is it clear? Now the formula method of 3-digit numbers giving 5 digits, when the repetitions are allowed, is nothing but NPR. Okay, this is the formula method. So this is nothing but, we know the formula, NPR is nothing but n factorial divided by n minus r factorial, isn't it? So this is nothing but n, we have n is equal to 5 divided by, it is 5 minus r is nothing but 3. So it is 5 minus 3 factorial. This is nothing but 5 factorial by, it is 2 factorial. This is actually will be nothing but 5 into 4 into 3, because 2 factorial cancels with the denominator. Now 4 3s are 12, 12 fives are 60 numbers. So there are 63 digit numbers that can be formed using these 5 digits, provided repetitions not allowed. Okay, so this is the formula method. Let's take the same concept by fundamental principle of counting. Okay, only for this particular question I will solve both the method, but from next question onwards I will consider any one method which I feel is very simple for the students. Okay, so now consider the same process: units, tens and hundreds. You have to fill by now the units place can be filled by. Now you have to note down this carefully because there is a difference between this and this. Okay, units place can be filled by any of the 5 numbers, which is 1 to 5. Okay, coming to the tens place, if one number is already filled here, then that number cannot appear here once again because he has told you repetition is not allowed. Then the tens, that means the tens place can be filled by any of the 4 remaining letters. Okay, once that is clear, now let me say there is another letter which has been fixed to the tens place. Then in the hundreds place, there are options for only 3 numbers. Okay, because 2 are already fixed. So hundreds place can be filled by any 3 remaining numbers. Okay, therefore the total number of 3 digit numbers would be nothing but 3 into 4 into 5, that is equal to 4 5 is a 20, 23 is a 60. So you can see here in both the methods you get the same answer. Okay, so this is all about solving the particular question in formula method or by the fundamental principle of counting. Okay, so from next question onwards I'm going to take one single method. Okay, right. So hope you don't have any doubts in this. Let's take up the second question. Here comes the question number 2. This looks similar, but please be careful. You have to read the question carefully. How many 3-digit even numbers? So there it was just 3-digit number. Here he is asking me 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6. Okay, if the digits can be repeated. There is only one condition here and one change is nothing but he just wants the even numbers. Okay, so I'm going to solve this question by the fundamental principle of counting. Okay, so let's approach the question here. Now, what is the total number of digits which is allowed? 1, 2, 3, 4, 5, 6. That is nothing but n is equal to 6. Now, what is the number of digits that is you want to arrange? 3-digit number. So it is r is nothing but 3. Okay, so now please be careful. Okay, so let us consider the same condition, units, tens and hundreds. So look at the numbers, digits which are allowed, 1, 2, 3, 4, 5, 6. Okay, now remember there in the units place, I could have taken any of the 6 digits. But here, because the number has to be even, what do you mean by even? If the number has to be even, then the units place number should be even, isn't it? So that means the units place can be either filled with 2, or it should be filled with 4, or it should be filled with 6. So the number of options unit place can be taken is only 3 numbers. So only 3 digits are allowed. That is, only 3 of the numbers are allowed for the units place. So once any of the number is taken here, there is no restrictions for the tens place. Again, please check here. He is telling you if the digits can be repeated. So because the digits can be repeated, once there is one number is fixed, you can still take the same number here. So here I can get any of the 6 digits. I can pick any of the 6 digits here. No restrictions for tens place. In the same way, even for hundreds place, there is no restrictions. Any of the 6 numbers, any of these 6 numbers can take the place of the hundreds place. So that means the total number of 3-digit even numbers, I repeat, the total number of 3-digit even numbers that can be formed is given by, just it is already available there, 6 into 6 into 3. Okay, this if you can multiply, you will get 108. So that is the total number of 3-digit even numbers that can be formed with the given digits. Okay, very simple question, but you should understand the question carefully. Then you can easily solve it. Only thing required here is using your common sense properly. Okay, well, hope you have understood this. Let's take up the question number 3. So here comes the question. How many four-letter code, I repeat, four-letter code can be formed using the first 10 letters of the English alphabet? So you have to, this is nothing but coding, okay? So four-letter code you have to make using first 10 letters of the English alphabet. Now, if no letter can be repeated, so the repetition is not allowed, okay? Either you can use this formula method here, or let us use the fundamental principle of counting. Now it is quite clear here what is the value of n. The total number of letters allowed is first 10 letters. Okay. Now the numbers which are arranged, that is for required is 4-letter code. So that is r is equal to 4. Okay. Therefore total permutation is given by, so remember total permutation is given by NPR, because repetition is not allowed. If no letter can be repeated, please don't forget this no. If you take away this no, if letter can be repeated is the question. So this will be nothing but 10P4. Okay, so this is nothing but, we know the formula of NPR, isn't it? So NPR is nothing but n factorial divided by n minus r factorial, isn't it? So that means you have to get 10 factorial divided by 10 minus 4 factorial. So this is nothing but 10 factorial by 6 factorial. Okay. So this will be nothing but, you can take 10 into 9 into 8 into 7, because the next 6 factorial will cancel with the 6 factorial. Okay. If you want, let me write this step just for this question, into 6 factorial by 6 factorial. So this and this gets cancels. You will have 10 into 9 into 8 into 7. Okay. So you will be having your calculators. If you use this value would be 5040. Okay. This would be the required number of coded numbers. Okay. Let us try the same thing by fundamental principle of counting. Now, because this is coding, okay, and it is taking the letters of the alphabet, you can either start from this place or from this place. Okay, both are same. So the first spot can be filled by any of the 10 alphabets. Okay, now for the second spot, now remember, since repetition is not allowed, since one letter is already fixed, only 9 is left over which can take the place or in this spot. Again, if one is fixed here, only 8 alphabets are remaining which they have the chance to be filled, occupying here. Okay, finally the last spot can be fixed by 7 alphabets. Is it clear? So that is the answer. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ? ಸೊ ಫಸ್ಟ್ ಸ್ಪಾಟಲ್ಲಿ ಯಾವುದಾದ್ರೂ 10 ಆಲ್ಫಾಬೆಟಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಫಸ್ಟ್ ಬಾಕ್ಸ್ಗೆ ಹಾಕ್ಬೋದು. ಎರಡನೇ ಪ್ಲೇಸ್ಗೆ 10 ಹಾಕೋಕೆ ಆಗೋದಿಲ್ಲ, ಯಾಕಂದರೆ ಒಂದು ರಿಪಿಟೇಷನ್ ಅಲವ್ ಆಗಬಾರ್ದು ಅಂತಿರೋದ್ರಿಂದ, ರಿಪಿಟೇಷನ್ ಅಲವ್ ಇರೋದಿಲ್ಲ. ಸೊ ಇಲ್ಲಿ ತಗೊಂಡಿರೋ ಆಲ್ಫಾಬೆಟ್ನ ನಾವು ಮತ್ತೆ ತೊಗೊಳ್ಳೋಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಸೊ ಉಳಿದಿರುವಂಥ 9ರಲ್ಲಿ ಯಾವುದನ್ನ ಒಂದು ತೊಗೊಳ್ಬೇಕು. ಸೊ ಇಲ್ಲಿ ಒಂದು ತೊಗೊಂಡಾದ್ಮೇಲೆ ಮತ್ತೆ ಮೂರನೇ ಸ್ಪಾಟ್ಗೆ ಇರೋದು ನಮ್ಮ ಹತ್ರ ಉಳಿದಿರೋದು 8 ಮಾತ್ರ. ಓಕೆ, ಬಿಕಾಸ್ ಪ್ರತಿ ಸರಿ ಒಂದೊಂದು ಫಿಕ್ಸ್ ಮಾಡ್ತಾ ಅದರ ಸ್ಪಾಟು ಕಳ್ಕೊಳ್ತಾ ಬರುತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರ ನಾವು ರಿಪಿಟೇಷನ್ ನಾಟ್ ಅಲೌಡ್ ಅಂತ ತಗೊಳ್ತೀವಿ. ಓಕೆ, ಸೊ ಫೈನಲಿ ದಿಸ್ ಆನ್ಸರ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಅಗೇನ್ ಇಟ್ ಈಸ್ ದ ಸೇಮ್. ಇಟ್ ಈಸ್ 10 into 9 into 8 into 7. Calculate it, you will get 5040. That is the required answer. Okay, again you can see here, you can use any of the two methods in the examination to get the solution. ಓಕೆ, ನೀಡ್ ನಾಟ್ ಯೂಸ್ ಬೋತ್ ದ ಮೆಥಡ್ಸ್. ಎರಡೂ ಮಾಡಬೇಕು ಅಂತಿಲ್ಲ, ನಿಮಗೆ ಯಾವುದು ಈಸಿ ಅನಿಸುತ್ತೋ ಅದನ್ನು ಎಕ್ಸಾಮಲ್ಲಿ ಮಾಡಿ. ಓಕೆ, ಫೈನ್. ಸೊ ಹೋಪ್ ಯು ಹವ್ ಅಂಡರ್ಸ್ಟುಡ್ ದಿಸ್. ಲೆಟ್ಸ್ ಟೇಕ್ ಅಪ್ ದಿ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಸೊ ಹಿಯರ್ ಕಮ್ಸ್ ದಿ ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 4. ಸೊ ವಾಟ್ ಡಸ್ ದಿಟ್ ಸೇ? ಹೌ ಮೆನಿ 5-digit telephone numbers, so this is about 5-digit telephone numbers, can be constructed using the digits 0 to 9 in the phone numbers. 5-digit phone number, remember, it's not your 10-digit mobile number. If each number starts with 67 and no digit appear more than once. What do you mean by no digit appear more than once? So ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಸಾರಿ ನಂಬರ್ ಬರಬಾರ್ದು ಅಂದರೆ ರಿಪಿಟೇಷನ್ ಅಲವ್ ಇಲ್ಲ ಅಂತ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಕಂಡೀಷನ್ ಫಾರ್ ರಿಪಿಟೇಷನ್ ನಾಟ್ ಅಲೌಡ್. Okay, so let us take up the data here. Here you can look here, total number of digits allowed is 0 to 9. 0 to 9, actually don't write there are 9 numbers, actually there are 10 numbers, because 0 also can be taken in a ಫೋನ್ ನಂಬರ್. ಓಕೆ, ಕೆಲವರು ಹೇಳ್ತಾರಲ್ಲ 99 ಸಿಕ್ಕಾಪಟ್ಟೆ ಝೀರೋ ಅಂತ. ಸೊ ಡೋಂಟ್ ಡೂ ದಟ್. ಝೀರೋ ಈಸ್ ಆಲ್ಸೋ ಅಲೌಡ್ ಇನ್ ದ ಫೋನ್ ನಂಬರ್. Now, how many digit number I want? So I want 5. This is nothing but my R. R is nothing but 5. Okay, we are going to solve this by using the fundamental principle of counting. Now see the beauty of this question. Now I need a 5-digit phone number. I can take any of the digits 0 to 9, which are 10 digits, but the condition is the each number with should start with 66. ಓಕೆ, ಸೊ ಫೋನ್ ನಂಬರ್ ಹೇಗೆ ಸ್ಟಾರ್ಟ್ ಆಗಬೇಕಂದ್ರೆ 67 ಇಂದನೇ ಸ್ಟಾರ್ಟ್ ಆಗಬೇಕಂತೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ದ ಫಸ್ಟ್ ಸ್ಪಾಟ್ ಆ್ಯಂಡ್ ದ ಸೆಕೆಂಡ್ ಸ್ಪಾಟ್ ಇಸ್ ಫಿಕ್ಸ್. ಓಕೆ, ಎಷ್ಟೋ ಜನ ಯಾಕೆ ಸರ್ ಹೀಗೆ ಬೇಕು ಅಂತಂದರೆ ಫ್ಯಾನ್ಸಿ ನಂಬರ್ಸ್ ಕೇಳ್ತಾರೆ. ಅವ್ರ ಅಜ್ಜಿ, ತಾತ, ಅಪ್ಪ, ಅಮ್ಮ, ಮಕ್ಕಳು ಎಲ್ಲ ಒಂದೇ ಥರ ಸ್ಟಾರ್ಟಿಂಗ್ ನಂಬರ್ ಇರೋ ಥರ. ಓಕೆ, ಸೊ ಜಸ್ಟ್ ಲೈಕ್ ದಟ್. ಓಕೆ, ಸೊ ದಟ್ ಮೀನ್ಸ್ there is no freedom. So no freedom or no choice for the first spot and the second spot, because first place should be filled by 6 and the second spot should be filled by 7. Okay, the remaining 3 letters I can fill any of the 3 letters. Okay, so the third spot ಈ ಪ್ಲೇಸಲ್ಲಿ ಐ ಕ್ಯಾನ್ ಫಿಲ್ ಎನಿ ಆಫ್ ದ, ಈಗ ಇವೆರಡು ಫಿಕ್ಸ್ ಆಗಿದೆ ಅಂದಮೇಲೆ ಉಳಿದಿರೋದೆಷ್ಟು? ಔಟ್ ಆಫ್ 10 2 ಈಸ್ ಆಲ್ರೆಡಿ ಫಿಕ್ಸ್. ದಟ್ ಮೀನ್ಸ್ ಐ ಹ್ಯಾವ್ ಎನಿ ಆಫ್ ದ 8 ನಂಬರ್ಸ್. ಓಕೆ, ಇರುವಂಥ 0 to 9ಅಲ್ಲಿ 6 7 ಬಿಟ್ಟು ಉಳಿದಿರುವಂಥ 8ಅಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದನ್ನು ಇಲ್ಲಿ ಫಿಕ್ಸ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಸೊ ಔಟ್ ಆಫ್ ದ ರಿಮೈನಿಂಗ್ 8 numbers 1 is fixed here. Now since 1 is already fixed here, now this number, the 4th digit, can be taken by any of the 7 numbers, because I told you repetition is not allowed. Okay, so 4th spot can be filled by any of the 7 numbers, and finally the 5th spot can be filled by any of the 6 numbers. Okay, so this is the required answer, the required 5-digit telephone numbers. So therefore the required 5-digit telephone numbers that can be formed is nothing but 8 into 7 into 6. Okay, so calculate this. So this will be nothing but 336 numbers. So ಈ ನಂಬರ್ಸ್ನ, ಫೋನ್ ನಂಬರ್ಸ್ನ 67 ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗೋ ಫೋನ್ ನಂಬರ್ಸೇ 5 ಡಿಜಿಟ್. ಇದನ್ನು 336 ಡಿಫ್ರೆಂಟ್ ಪ್ಯಾಟ್ರನ್ಸ್ ಬರ್ತದೆ. ಅದರಲ್ಲಿ ಯಾವ್ದು ಬೇಕಾದ್ರೂ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಸೊ ಐ ನೀಡ್ ನಾಟ್ ವರಿ ಅಬೌಟ್ ವಿಚ್ ಒನ್ ದೇ ಆರ್ ಗೋನ್ ಟು ಸೆಲೆಕ್ಟ್. ಐ ವುಡ್ ಜಸ್ಟ್ ವಾಂಟ್ ಟು ನೋ ಹೌ ಮೆನಿ ಆರ್ ಅಲೌಡ್. ದೇ ಆರ್ 336 numbers that is allowed with this condition. Okay, don't you think this question is quite interesting? Yes, so this chapter itself is an interesting chapter. Okay, ಇದು ತಲೆಗೆ ಹುಳ ಬಿಡುವಂಥ ಚಾಪ್ಟರು. So those who like challenging questions, so this is the chapter for you. Okay, so we are done with question number 4. Moving on to the question number 5. So what does question number 5 say? A beautiful question, the same type of question you can find even in the chapter of probability. So look here, a coin is tossed 3 times. So you are tossing a coin 3 times and the outcomes are recorded. Okay, how many possible outcomes are there? So this is nothing but writing the sample space for tossing a coin thrice. Okay, now I will give you a hint. It is just like a formula to find out the total number of possible outcomes while tossing a coin. Okay, so please note down this formula. The total number of outcomes when an unbiased coin, so ಇದನ್ನು ನಾನು probability chapter ಹೇಳ್ತೀನಿ. Unbiased means a proper coin. ಕೆಲವು ಕಾಯಿನ್ಸಲ್ಲಿ 2 ಕಡೆ ಹೆಡ್ ಇರೋ ಕಾಯಿನ್ ಅಂತ ಹೇಳ್ತಾರಲ್ಲ, ದಟ್ ಈಸ್ ನಾಟ್ ಅಲೌಡ್. ಸೊ ಅನ್ಬಯಾಸ್ಡ್ ಕಾಯಿನ್ is tossed is nothing but, please remember, this is nothing but 2 power of n. This is the formula to find out the total number of outcomes when a coin is tossed. Okay, now what does n means? N indicates how many times it is tossed. Okay, so therefore the total number of outcomes is equal to, so required number of outcomes is equal to 2 power 3, because n is equal to 3. You are tossing a coin 3 times. So this is nothing but 2 cube is nothing but 8. So there are 8 outcomes. So the sample space of tossing a coin thrice is nothing but 8. You're going to see this question in detail in the chapter of valid question. Okay, look here. Question goes like this. Given 5 flags of different colors. Okay, you are given with flags with different colors, 5 flags. Okay, how many different signals can you generate if each signal requires the use of 2 flags, one below the other? Okay, so please understand the question carefully. Here let us write down the required data. Here n is equal to, so what is the total number of flags given? The total number of colors we have is n is equal to 5, and we are going to arrange 2 colors among us. Okay, again you can use either the formula or the fundamental principle of counting. Okay, now look here dear students, you will be having flags with is asking you to have colors one below the other. Are you following? You are supposed to have flags one below the other. Okay, so on the top layer you can use any of the 5 colors. Okay, now here you might be wondering, sir, why the repetition is allowed or not allowed is not given. Sometimes they will not give you, you have to use your common sense. If you use the same color again, does that show you different colors? Okay, there is no changes. That means let me assume red and yellow here, or yellow here and red. Okay, it makes a difference, isn't it? If you use the same color twice, then that does not make the difference of the colors of the flag. So that means repetition here is not allowed. I repeat, in this case repetition is not allowed. So the top layer can be taken any of the 5 colors. So once one color is fixed, the bottom layer can be taken by any of the 4 remaining colors. Is it clear? It's a very simple question. I don't want you to confuse here. Therefore, total number of permutation would be nothing but 5 into 4. Is it clear? So 5 into 4, that is nothing but 20 different colors of flags you can make with the given condition. Okay, very simple question, dear students. As I tell you, first you have to understand the question and use the logic here. Okay, these are all logical questions. Okay, right students, it's time to wind up the session. So before I close this session, I'll give you one similar question for you as a homework, and then we can say bye. So here comes the question for you as a homework, dear students. Please check here. Given 4 flags of different colors, how many different signals can be generated if the signal required or requires the use of 2 flags, one below the other? Actually, this is a worked example in a textbook, very similar to the previous one. Okay, you can direct tell it in a simple way. Here 5 flags were given and 2 were written, so you took 5 into 4. So here only 4 colors are different given, so that will be nothing but 4 into 3. Okay, I'll give you this as a homework. You can take it. I've give you the hint for the answer. You can work it out by your own self. Okay, hope you have understood this session, dear students, and it was also informative and you enjoyed it also. As I told you, these were all challenging questions and a very easy one also. Okay, students, your comments and your how you felt about this class are open in the comment box. Kindly comment so that let us know how you felt about this class. Okay, don't forget to share this video with all of your friends, which would allow us and give us a support to make more videos. Your every single like will account to us. Okay, it would be supporting us. Every like from you will give us boosters to make more videos of such kind for your benefits. Okay, so hope before I say this, you have already liked the video. Thank you for that. You are always welcome. Okay, right students, so thanks for watching the video. We will meet again in the next video where we are going to solve the next exercise questions in the next time. Okay, until then, stay tuned and keep watching. Take care of your health. God bless you all and bye.